So in behavior of a graph, and asymptotes refers to how the graph is when it's about to approach either positive infinity or negative infinity. So this is positive infinity, and I'll do this in blue. This is negative infinity. And so you see negative infinity kind of goes more towards here. So even if your graph is coming here, it has to go to a certain point. This green line could even be more towards here and point out. Okay, but it's as it approaches. So even if it starts up positive and comes up, that's negative infinity. And then over here on this other side, if it comes over and starts even negative but goes up towards positive infinity, like this way, then we have positive infinity. Okay, it's a line that approaches the graph as an asymptote, but it does not really touch or intersect the graph. Okay, now here's the thing, an asymptote can be horizontal, which, as you know, if you get confused, just remember horizon means it comes up on the side, it comes up from left to right. Vertical means straight. And oblique is that shape I was just kind of showing you, like this. Even this is oblique. And even this can be oblique. So don't worry about the size. Just remember, just as long as it's not a straight line and it's not a vertical line, then it's an oblique line. Now here's the tricky part you have to remember. A horizontal asymptote is going to happen when this is the denominator, and keep in mind denominator is down below, the denominator's degree is greater than the numerator's. If you can remember denominator is down, you don't have to worry about which is which. And don't feel bad if you get them confused, because sometimes they don't use these terms again until you get to algebra. So this is going to be horizontal just because of this degree. This power is here. And remember, degrees can be like, you can have 6 degrees, that's higher than 5 degrees. And I'm kind of writing it backwards because that's how you write them on a graph. X to the 6th, and then you come over and write this guy is, you go plus x to the 5th. And that's why I'm writing them like this. And then this that I'm writing in blue is a coefficient. So you don't worry right now if the coefficient is higher or less. And then you'd have like to the 4th power. So you're talking about a degree, and that's a level. So this is 5x to the 4th power, x to the 5th power, x to the 6th power, and then you could say it equals 0. You'd probably go down lower, but that's just what the point is. So this degree here is higher than this degree, so it's horizontal. Okay, so I didn't mention this before, but you need this is a horizontal asymptote whenever you have the both powers and both are equal. So this is 2x to the 2nd power over 8x to the 2nd power. So your asymptote is still going to be horizontal. I didn't mention that. So like as it approaches, it's going to go here on one side and then here. Remember, it still can't touch the graph. So that's kind of not an asymptote, but it's approaching the graph. Okay, on this one and on this one. Okay, what about this one? This is a slanted asymptote because the degree now is up top. So it's going to be slanted or oblique. Oblique and slanted mean the same thing. Okay, so you have the first half of graphing it done. Okay, we're going to go ahead and do this problem, and then I'm going to tell you what's going to happen. It's also horizontal if they're equal, if both of these are equal. But let me go ahead and do this graph. Okay, here's what the graph, and remember, you're dividing by a certain side. So this is this. If you were to write this 4 divided by 2, it's a fraction, but it also means how many times does 2 go into 4? Okay, so remember how you're supposed to write things, and I know this is a lot, and of course it goes 2 times, and 2 times 2 is 4, so that's 0. Do you see that step I did? 2 times 2 is 4. So 2 times 2 is 4, you subtract, and you have a remainder of 0. Same thing you're going to do here, only you have these people here, this variable with a degree, and then you have a variable with, really, this is a degree of 1. Okay, 2x times a half is going to give you an x. This is one of the hardest things in the world to remember, because 2 halves times 1 half equals 2 over 2, which is equal to what? 1. This is 1. This is 1x. This is 1x. You subtract, you have a remainder of 0. Hard concept, so I'm going to pause for a minute. Here's what's up top. Your quotient is going to be here. What is your quotient? Your quotient is the answer. We also have to remember powers rules. When you're dividing these powers, you're subtracting. And I put this here: when we divide, x to the 4th power divided by x to the 3rd power is going to be 4 minus 3 is equal to 1. Okay? I drew this here, 2, here it is again, so you get in your head, this is 2 over 1. Why do you make it 1 half? And why am I putting this dot here? The dot means times, because didn't you times in the last program? Like when I said 2 goes into 4. Aren't they inverse operations? 2 times 2 equals 4. So 2 goes into 2 4 times. Remainder 0. I took this class years ago. Drove me crazy, because one of the things you're inclined to do is to get all these powers messed up, forget what you're doing, and not think about. If you have to ignore the powers for now, you can go back and do them later. I wouldn't suggest it, but try to think about what's going on. Okay, guys, you have a 4 here. This is a 3. This is going to leave you with a 1. 0 done. Now we need to use this term, because we took care of this term. And we're not using synthetic division, we're just using regular division right now, but we're using division of terms. It looks like synthetic division, but it isn't. So let's go here. 5 times a half is negative 5 halves. Now let's go on and look at what goes on next. 5 halves times 1 half is 5/2. Why is that? 5 over 1 times 1 half. Where are you getting this 1 half from, Kendra? You're getting it from here. 5 halves. 5 times 1 half is 5 halves. Equals 5 over 2. We subtract. This is minus 5/2, but here's why this is here. Because this says subtract. Multiply here, subtract here. But when you subtract this, you have 2 fractions with different denominators. So the denominator has got to be different. So we've got to change it. 5 halves stays the same. 2 is your bottom. 3 times 2 is 6. I put that here. 6 minus 5 is a half, so this is your answer. And it's a positive a half. This is a half minus 1. Unfortunately, we're not done yet. This stays here. This is not your quotient. This is not the quotient. This is the dividend. Let's not get into these terms. And this is this is divisor, dividend. Your quotient is down here. This is just what you're doing to go along with the stuff. This is your remainder, which is half x minus 1 anyway. Or you could say this, you could come back up here and put minus 1 and make it the quotient. But right now, because you divide it out and you have a remainder, your quotient is at the bottom. So that's a quotient. And this is how we do our asymptote. Because this is your quotient and it's oblique, which you already knew, it has to approach the line at negative infinity. So as it comes here, it's going to kind of go this way, and then it's going to kind of go this way. If you wanted to draw it, or if your teacher asked you to draw it approaching both, that would get kind of hard. So you don't have to worry about that. Just know what's going on as it approaches this, because your teacher also might give you a multiple choice and say which one, and probably they wouldn't put them both, because remember, it can't touch the graph, so you can't do that. Okay, so it has to be one of the other. Next slide is just questions we went over.